Newton-Raphson method. Newton-Raphson method is another numerical method used to solve the equations for finding the roots of an equation. Normally, its application, Newton-Raphson method's application is they help to solve the non-linear equation. Help to solve the non-linear equations. It's one of the applications of this Newton-Raphson method that it helps to solve the non-linear equations. Before solving the question, we must know its graphical representation and how we are going to derive the Newton-Raphson formula used to find out the roots of an equation. Consider a curve, like this is a curve y is equals to f of x. Consider this curve. Just draw a tangent to that curve. This is the tangent to that curve. For example, it is touching this curve. The point on x-axis is x0 and this point on y-axis is, let's suppose, f of x0. Then this point will be x0 f of x0. This is the y coordinate of this point and this is the x coordinate of this point and this one is the y coordinate of this point, the point at which the tangent is touching that curve. We will derive the Newton-Raphson formula using this tangent to that curve. We know very well the tangent is normally called the slope of the curve. The tangent is also called as the slope of the curve. We will use equation of slope. We know very well that slope is normally represented as m and it can be also represented as tangent and it can also be represented as dy by dx, or we can say like f dash of x. Slope is equals to, we know very well slope is always equals to change in y coordinates divided by change in x coordinates. It is change in y coordinates and divided by change in x coordinates. In y coordinate, this point is f of x0, final point, and the starting point will be considered as y, or we can say like f of x. So change in y coordinate will be y minus f of x0 divided by change in x coordinate is x minus x0. This slope can also be represented as in terms of derivative. So we will write f dash of x. So f dash of x equals to y minus f of x0 divided by x minus x0. This x0 is that particular point. On this we are finding some function value. Now rearrange it. I will move this x minus x0 here and f dash of x0 down. So x minus x0 will be equals to y minus f of x0 divided by f dash of x. X will be equals to, move this x0 here, x will be equals to y minus f of x0 over f dash of x plus x0. Or we can also write it like x equals to x0 plus y minus f of x0 over f dash of x0. This derivative value is basically on that particular point x0, so we will write it like f dash of x0. So replace f dash of x by f dash of x0 also here. Now this point, this tangent curved line is cutting the x-axis at this point. And at this point y is equals to 0. So replace y equals to 0 here. We'll get x equals to x0 minus f of x0 divided by f dash of x0. Now this is the first value that we will get. the first root, that is at the starting point x naught. So we can also write it like x1 equals to x naught minus f of x naught divided by f dash of x naught. So we can derive the general formula out of this derived formula as xn plus 1 equals to xn minus f of xn divided by f dash of xn. So this is the Newton-Raphson formula that will be used to find out the roots of an equation. So starting from its example, consider an example. Let's suppose f of x is equals to x cube plus 2x square plus 10x minus 20. We have to find out the roots of this equation. First of all, we know that Newton-Raphson formula is xn plus 1 equals to xn minus f of xn divided by f dash of xn. For the first value of x, x1, we need some x naught, starting value, initial point. For that purpose, we must have some interval. And for finding an interval, you know very well, we have discussed it in the previous methods as well, that how we're going to find out some interval if it is not given. We will just take some numeric number and we will put it in this function and we will observe the behavior. Let's suppose I am taking the interval from 1 to 2. F of x will show different behavior at 1 and at 2. So I will consider this interval from 1 to 2. It's up to us that which interval we are considering. Like at f of 1, it will show a negative behavior, and at f of 2 it will show a positive behavior. So between these 2 points we can find some interval here. Now we need a function value and the derivative value. The function is given, we must find the derivative of the function. Derivative of the function x cube will give us 3x square plus 2. X square will give us 2x plus 10. Derivative of x is 1 and the derivative of constant will be 0. Simplify it, we will get 3x square plus 4x plus 10. Now we will use this derivative function and this main function in questions in solving the roots of the equation. Now the choice of the initial value. We know very well that we have the interval from 1 to 2. Now choose any value, starting value out of this interval. It's up to us that which value we are choosing. Let's suppose I am choosing like 1.5 belongs to this interval 1 to 2. So I am let x naught equals to 1.5. You can take any value out of this interval. It will be your choice. Now the first iteration, x1 will be x naught minus f of x naught divided by f dash of x naught. x1 will be equals to x naught is 1.5 minus f of 1.5 divided by f dash of 1.5. This will be equals to 1.5 minus. Now consider the function and replace x with 1.5 here. Replace x with 1.5. I'm just writing the format. I was having the function as x cube plus 2x square plus 10 into x minus 20. Now replace x with 1.5. 1.5 here. Now consider f dash of x. Its format will be 3x square plus 4x plus 10. Now replace this x with 1.5. Now simplify this fraction using your calculator. I am solving this question, finding this root up to 4 decimal places. up to 4 decimal places. If the answer is repeated, then I will attain my root of the equation. So here, after simplification using the calculator, I will get 1.3736. Now find the next iteration, that is x2. x2 will be equals to x1 minus f of x1 divided by f dash of x1. x1 is 1.3736 minus f of x1 is 1.3736 divided by f dash of 1.3736. Again use the format of f of x and f dash of x and replace it with this x value now. For doing that, x2 is equals to 1.3736 minus f of x was x cube plus 2x square plus 10 into x minus 20 divided by f dash of x, format of f dash of x, that is 3 into x square plus 4 into x plus 10. Now replace x with this value 1.3736, 1.3736, 1.3736, 1.3736, 1.3736, 1.3736. Now simplify it using your calculator. We will get 1.3688. Now the starting value was 1.5, then we got 1.3736, now we got 1.3688. We have to find out more roots until we attain the exact root. That is, the root is repeated. So move on to the x3. x3 will be x2 minus f of x2 divided by f dash of x2. x2 is 1.3688 minus f of 1.3688 divided by f dash of 1.3688. Do the same step as previously done. Replace the x with 1.3688 now. Then we will get here 1.3688. So we got the same exact value now. The root is repeated. Since the root is repeated, so we will write root will be 1.3688. It means the x is equals to 1.3688. I hope you understand this method that we use the finding the root of the equation by using the Newton-Raphson method.